Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon. Okay, today I would like to talk or to make a presentation about lab 1, which is introduction to high voltage in FTKEE. Okay, so basically the introduction, this lab are required for us to recognize and trace clearly the important section of frequency converter by and referring the video as shared as by our lecturer or from the manual book. Okay, this lab also was describing an important aspect on how to handle high voltage lab and its instrument. A special concern is regarding on the application of the kit 4.0 high voltage construction kit, which was the latest technology from Hefli Hippotronic, Switzerland. Okay, we move to the first task, which is the trace power cable circuit. Starting from isolate switch 415 volt to the power block terminal and distribute to the control circuit system and internal transformer of the frequency converter. Next is the connection from the internal transformer to the out terminal block of the frequency converter. Okay, first cut the system of the electric mains, then disconnect the cable connection between the regulating transformer and the test transformer. Connect a voltmeter to the output of the regulating transformer instead of the cable connection. Okay, for the selection of the voltage meter, it is necessary to pay attention to the maximum output voltage of the regulating transformer. Connect the system with the electric mains, then switch on kit control software according to the manual and unlock emergency button. Make sure all interlock contacts are closed. Modulation index is at 0 positions. Switch the primary breaker and the secondary contactor through the kit software on. Okay, then increase the output voltage at the regulating transformer by the kit control software continuously and check the correspondence of the voltmeter and voltage indication on the control unit. Okay, and finally decrease the output voltage at the regulating transformer continuously to 0 by the control unit. Then switch the primary breaker and the secondary contactor through the kit control software off according to the kit control software manual. Okay, the second thing is about lamp and alarm. Lamp and alarm act as an emergency light. It is very important for safety assurance. This device will switch on automatically when the system experience a power outage. Okay, there are three colors that indicate three different conditions. The first color, which is red, which means in a condition of failure such as an emergency stop or machine failure. The second color was yellow, and it gives warnings like condition of over temperature or over pressure. Okay, the last color, which is green, is a normal operation of the machine or a process.
Hi, Assalamualaikum. I'll be continuing to the next component, which consists the interlock system and emergency button. An interlock system is very crucial for the system. It is a feature that makes the state of two functions mutually dependent. A safety purpose where it prohibits people to enter when testing on progress. It connected to a regulator and alarm, and it called as a double security. Basically, interlocks operates when the door closes, so then it triggers the normally closed contactor. When they are in the normally closed conditions, we are required to reset the button on the alarm, and an injection is allowed once the light turns green. Next, for the emergency button, which is also relevant for a safety purpose. It is intended to avoid harms or to reduce any hazard once it's activated. it will immediately start the emergency stop sequence. Onto the right bottom picture, there is an emergency button connection where there are two normally closed contactors that operate together. It will operate with dual channel operation when there is any inconsistencies between two circuits or cross short detection if any fault occurs.
Today I will talk about grounding system. How it operates. Grounding system use a copper braided. Next, grounding is connected to the terminal block. 3. Grounding or earthing must be in very low potential. 4. To avoid ground loop between different grounding points, the kit is grounding at only one position through a ground rod. Next, the rod must be ground resistant less than 2 ohm. 6. Grounding for this lab can mix with the grounding for the building. 7. For this lab grounding, the wet condition will at least achieve 1 ohm. And when the dry condition will achieve at least 2.3 ohm but less than 2.5 ohm. Finally, the main reason for the grounding is avoid the current floating at the device.